So I got a few more minutes before I get started. Set a nice custom laser color. Fun. Hey, welcome to the chat. Gonna get started in a couple of minutes, but I've got 7 new exhibits to show off today, so this one will definitely be a little bit longer of a stream than some of the previous ones. One of these days I'm going to get a better mic. I've just got the classic blue snowball, so I'm sure the audio isn't great and the lighting is also not great either. I've got my window open for our 4 p.m. winter sunset. Oh well. Just a few more seconds to go. And let's do it. Hey guys, my name is Benjamin Moeller. I'm a paleontologist and creator of SHADOWBOX, which you are seeing streaming right now. This is a free virtual museum that you can download on Steam through early access, currently only available for the Windows operating system. One of our goals for 2026 is to try to get Mac and hopefully Linux support going as well, but for the moment it's just on Windows. And if you don't have a Windows machine, or if you have a PC that isn't able to run the game right now, again, I am not actually a game developer, I am a scientist, and so all of the stuff that you're seeing is stuff that I'm kind of learning on my own in my free time, and I'm really motivated to try to bring the fossils that I work with on a day-to-day basis into a space that anybody can see. And of course that's ambitious, and there's a lot of different techniques that I've had to come up with in order to do that. So for everyone who isn't able to play the game, and again, if you want to play it and you have the right setup and the right operating system, you can check the Steam link is going to be in the chat. I'll also add it, pin it as a comment on the video. So you can download that and try it, and please head over to the Steam forums to let me know how it run, let me know what your computer setup is and how well it did, so that we can incorporate that feedback. And if you're not able to play, for whatever reason, I'm going to go through and show you all 7 of the new exhibits that just opened up. I pushed an update yesterday for beta 1.65. In the new year, I'm going to start using a less stupid numbering system that's not just arbitrarily going up by 0.5 every time I push an update, no matter how big or small. But for the moment, you can see up here in the top right corner on any of these videos and streams, you can see the version, so you know how old of a video you're looking at. So we're going to go ahead and enter the mausoleum, and here are where all the new exhibits are. Again, there's 7 in total. This one in the Louisville limestone is the first exhibit I've opened in the Silurian. There's a brand new one in the Carboniferous called the Westerville. There's a new one, our 3rd, in the Permian called the Denadoo, and it's actually the first exhibit I've opened on fossils from Australia. There are, skipping ahead in time, 3 new exhibits here at the end of the hallway from the Cretaceous period. And the Cretaceous is just going to be the most stacked period by far, I'm guessing. Throughout development, there's just so much material I have to work with that's from the Cretaceous. And the youngest that I have as part of this batch of 7 is the first exhibit I've opened in the Paleocene, and that is the Nacimiento Formation. And in previous streams, I've gone from the oldest to the youngest. I actually think this time I'm going to go from the youngest to the oldest. So I'm going to go ahead and start here in the Paleocene. Eventually, I'm going to try to work on creating a guide so that people who don't know the geological time scale like the back of their hand can still navigate and find what they're looking for. If you're like, I want to see ammonites, I want to see dinosaurs. For the time being, I'll do a little bit of narration. So this is one of several exhibits today that reflect fossils found in a deposit in New Mexico, and this is the youngest, the Nacimiento. So let's go ahead and enter this exhibit. The Paleocene is just one of the most fascinating periods in Earth's history because it comes right after the mass extinction that killed off the non-avian dinosaurs. So about 66 million years ago, there's a big asteroid that hits planet Earth in the Gulf of Mexico, and it causes massive ecological damage. It wipes out all of the large vertebrates, the dinosaurs that we think of, although, of course, we know now that the smaller members of the theropod family tree, the birds, a certain number of birds, not all of them, make it across the KPG extinction, is the name of that event. And in the Paleocene, within several million years, so that happened 66 million years ago, and the Nacimiento Formation, these fossils are going to be around 63 to 61 million years old. So this is within a few million years, which on a human time scale, right, is a pretty broad stretch of time. But in terms of evolution and in terms of geological time, 3 million years is not that much. So if we look at our map here, I'll use my laser to point out right around here is where that bolide impacted here and created the Chicxulub crater, and we are over here in New Mexico. So this is an ecosystem we're about to explore here that is not all that far away from where the mass extinction for that actual impact happened, and only about 3 million years, again, only about 3 million years after it happened. So these are all species that are considered survivors of that extinction. And the first one you see when you enter the Nacimiento is this skull. This is the first turtle skull I've had the pleasure of 3D scanning. It's in 2 pieces. And this is a turtle called Neuronchilus torahonensis. And you can see it in 2 pieces. Here, this is the top of the skull. And it's not totally complete, but it's in fantastic shape considering some of the other turtle bits that I've worked with in my time. This over here is the eye. Right there is kind of a nasal opening. On the right side here, you can see where that eye orbit is, but it's not complete. And then you can also flip it over and see what the underside looks like. So in SHADOWBOX, you can not only walk around the exhibits like so, you can also inspect, and that opens up these pages where you can rotate the stuff and look further. There's information, of course, over here on the left side. Please don't crash. I accidentally clicked off. Over here on the left side, that shows you additional information. You can hit a button to hear me pronounce how this stuff sounds.
Neuronchilus torahonensis.
That would be an interpretation of how to say it. I'm just going to repeat this anytime. There is no proper way to pronounce Latin names. Nobody knows how Latin was actually pronounced. So that's just what I'm going with. And I've got a pretty good understanding of what the pronunciation should be. But, there's a little bit of interpretation to this stuff. So that's the top part of the skull. This is the lower jaw here. You can see this species is edentulate. There are no teeth in this jaw. And you can see it forms a beak right there at the tip. So really cool stuff. There's an article that you can read that goes further into this. Any of these articles that I link to here in SHADOWBOX should all be free to access. I have a lot of content on Patreon that is just for subscribers, but anything that is linked to here in SHADOWBOX should always be free. So if there's a link to an article that you can't access without a subscription, just go ahead and let me know so I can correct that, because that's not supposed to be the case. Over here on the left, we've got, and by the way, I keep hitting this button, C. So if you want to go into the free camera mode, for example, if you are a TikToker and you want to do a video on Acanthosukis that's on display here, and you want to be able to, take a screenshot and do your video in the exact position, in the exact framing that you want, this is a good way to do it. So it's just let you kind of no-clip around. Hit C again if you want gravity to continue to exist. So this is Acanthosukis. I have scanned 2 of their osteoderms and also the left and right femur. So I've spent a lot of time working on croc osteoderms, and so these are really cool because they are very distinct from the ones that I have worked with in the Cretaceous of New Mexico that are around 20 million years older than this. This is clearly a completely distinct thing. You can see that keel, which is the upraised portion in the middle, is very different from the other species that I work with in the Cretaceous. So Acanthosukis, which is currently believed to be an alligatoroid, so it is related to alligators, but it's not on the actual branch that leads to alligators. And I have them labeled the right and the left femur. Now you might look at this and say, but this one's on the right, or this one's on the left. Why is this the right femur? When we do anatomical labeling of what's left and right, it's always from the perspective of the organism, and things like distal, meaning far away, is far away from the core, whereas proximal is going to be closer to the core and things like that. So this is the left and the right femora, the femurs, from the perspective of the animal themselves. It's the same thing where, like, my left leg and right leg are going to be swapped when you're looking at it because you have a different perspective. So that's Acanthosukis, very distinct from Cretaceous forms, whereas Neuronkylus, interestingly, there are actually fossils of this turtle that have been discovered earlier from the Cretaceous. There's actually several species of Neuronkylus in the Cretaceous, and one of them is found in the Menifee Formation. So over here you can teleport to the Menifee, and you can see the older species of Neuronkylus, one of them, Neuronkylus boweri. So this is an example of a genus, not the species, but the genus, the broader group, was able to survive. This is a direct survivor of the KPG extinction, whereas Acanthosukis we don't see in the Cretaceous. That's something that is newly evolved, whereas Neuronkylus torahonensis is a unique species, yes, but it is from a group that existed here in the same area in the Cretaceous and was quite successful. The last species that we have on display in the Nacimiento is called Kimbitopsilus. This was one of my favorite things to scan this year. This was a treat because it's the first mammal fossil that I've been able to put in an exhibit. There are mammal fossils available to see in the lobby, but this is the first one on display. And it's a Paleocene mammal. So we think of the Cenozoic as commonly stereotyped as the age of mammals, and this is the very beginning of the age of mammals. But Kimbitopsilus is actually quite different from... oh, we got a bug.
Kimbitopsilus simonsae.
Alright. Well, this is just one of the things that happens with early access programs, is that every now and again, stuff bugs out. So again, that's the kind of thing that's informative for me. To know stuff that needs to be fixed and so forth. All I did was basically exit out to the menu, and it's just going to spawn me right back in. So I'm going to go ahead and run back to the Nacimiento. But essentially, Kimbitopsilus is not like us. It's not like placental mammals, and it's also not like marsupials. And it's also not like monotremes. So today there are 3 major types of mammals. Most are placental mammals like us. You have marsupials, and that's a term that most people have heard before, like kangaroos, which have pouches and have a different sort of reproductive cycle. And then you have monotremes, and there's very few monotremes that are still around. One of which is the echidna, and another is the platypus. So some very ancient type of animals. These are mammals that still lay eggs. So you might call them primitive. word that we use in evolutionary studies is basal to describe a species that has more ancient features. And unfortunately right now it looks like the QR code prompt is just sending me to the blank Patreon page. So that's another thing I'll have to look into here. But there is an article that you can scan to read more about Kimbatopsilis. Kimbatopsilis is none of these. It actually belongs to a completely extinct mammal order called the multituberculates. And multituberculates were a successful group in the Cretaceous. So this is a type of animal that, their direct ancestors were very successful living alongside the dinosaurs. And they don't persist that long into the Cenozoic. So the fact that we've got this relatively large multituberculate animal here in the Nacimiento is really interesting. And you can see it has these big blocky molars. These are the molar teeth. Over here you can see a bit of a diagram. So you have two different parts of the upper jaw, and then this third right here with the incisor. This incisor is just beautiful. This is not, the coloration here is not an artifact of any of the scanning that I did. It is actually this kind of bluish purple. So yes, this is an incisor, and the skull bone that it's embedded in is the premaxilla, which is a bone that mammals don't have, the mammals that are around today. We don't have premaxillae. So that's just one of the cool, unique features that Kimbatopsilis as a multituberculate has that we, as another type of mammal, do not. So that is the first entry into the Paleocene. Again, this is a really very fascinating period of time, and I hope that I get to scan and research more fossils from that period in the future. But for now, we're going to go back in time a ways. We are going to cross that KPG boundary and descend into the Cretaceous. So we're going to start at the youngest of these, the Kirtland Formation. So this is another in New Mexico, but rather than 63 million years old, these fossils in this gallery are about 73 million years old. So welcome to the Kirtland Formation. This is definitely the era of dinosaurs, although I was luckily able to include at least a few things that aren't dinosaurs. This is a big vertebrae from a fish called Melvius. Melvius is an ancient sort of bowfin, and this is a big ol' vert that comes from the middle of the back, which is really cool. And as usual, you can oftentimes see, just because this is what or collections managers do, sometimes they will literally paint white out and write the specimen number of the fossil on the fossil. I understand why they do it. I don't love that they do it, but that's just part of what it is. That's just part of how it appears to me as a researcher who visits these collections. So there you go. There is a backbone from a fish, and everything else in here is dinosaurs. I imagine people are going to want to see the Tyrannosaurids first and foremost. This is a photo of a nearly complete skull of Bistachioversor. And when you go into this gallery, again, we've got a QR code. Let's see if this one will launch correctly, or if it'll just send you to the Patreon page. Bistachioversor is a tyrannosauroid, so it is a close relative of T-Rex, but it's slightly outside of that family. The Steam overlay can be kind of hit or miss, so this is not really something I have direct control over. This is more whether or not, Steam is working optimally on a particular day. But you can just, scan these QR codes just with your device. I've got my phone up, and here we go. Here is a free article about Bistachioversor that you can read. So it'll go into more detail because there's only so much, information that I can cram onto the walls of an exhibit like this. These are mostly for displaying the actual bones, and so that's exactly what you've got going on right now. So unfortunately, I was not able to scan this skull. This is on display under a glass case, but I was able to scan earlier this year a bunch of individual pieces of the skull. And this is kind of a unique way that I've chosen to display them this time. Basically, every new exhibit that I build has something unique because they're always constructed around the specific number of fossils that I have. So they always start off with something of a template, but in this case, I had, let's see how many are here. 3, 6, 7 different skull bones, and then 2 of these are actually neck bones. So I guess 5 skull bones, 2 neck bones. And you'll see different kinds of ways that I've decided to do a layout in other exhibits, but in this one I thought, let's just go ahead and put them in kind of a grid, and I'll have it labeled on the bottom what they are. You can obviously jump up and look closer. Here I am failing to do something extremely basic. That is actually this piece over here. While I do these streams, I am writing down different bugs that I have to fix here. So, for example, here's a piece that is a fusion of the right quadrate and the quadratojugal. You look at that and you go, I don't know what that is. Well, it's labeled up over here. It's this side over here. The only one in here that's a little hard to tell is the ectopterygoid. It's actually part of the palate on the inside, so you're not really able to see that from that view. This is a really cool bone because it's one of the ones that has been found in the field by some volunteers that I've worked with in one of my study areas. We have found a Tyrannosaurid ectopterygoid, so it was really cool to get my hands on a second one to scan and get a nice close look. So these are all different bones of Pistachioversor. Again, this one is kind of from the palate. That's the ectopterygoid. These 2 are cervical vertebrae, and that means that they are vertebrae, so bones in the neck, as opposed to dorsals in the back, sacrals in the hip, and caudals in the tail. So these are both fairly large. These were very fun to scan, and they're a little bit squished, right? They're not perfect as they would have been in life, but you can still see that's the neural canal right there. So the all the important parts of the nervous system that send information back and forth from the body to the brain, it all goes through this little hole right there, which supplied that brain up there with the information to help it go around, navigate its environment, find food, avoid predators. This is the surangular, so this is part of the lower jaw. This is, again, incomplete, so the dentary is missing, but we have the surangular, the quadrate and quadratojugal. We've got the postorbital. The postorbital is really cool because this is the bone that sits over the eye, actually, and you can even see this kind of rough texture up here is part of like would have been sort of a crest over the eye. And then we've got the premaxilla. This is just the very tip of the snout. This is the right premax. This is like the right front forwardmost facing part of the snout, which is really cool. There's the premax. So that's everything going on with Pistachioversor. One of these days, and as development in SHADOWBOX goes on, all of these exhibits will obviously be getting updates as I think of new techniques and I just have extra time to refine and work. So there will be more of Pistachioversor to see, and there will be a more close-up view, more information from all of those bones, because there sure is a lot to tell. But it's not the whole story, and I had other things that I wanted to get to. So this, for example, these are some bones from the skull of a hadrosaur. These are the duck-billed herbivore dinosaurs. This is Nashoibitosaurus. It's a little bit of a tongue twister, and it's also a misnomer. So I, subjectively, as a scientist, dislike it when people name dinosaurs just after the place they were found, or after some other kind of attribute that might be disproven later. So Nashoibito is one of the layers in New Mexico, in the San Juan Basin of northwestern New Mexico. So it's a geological word for a particular layer of rock that this animal was not found in, actually. It was originally believed to be, and that's why it was named after the Nashoibito member. But this animal actually comes from somewhere else entirely. So unfortunately, the name Nashoibitosaurus doesn't really make a lot of sense. It's actually like misleading. But in scientific works, you don't get to change the name just because you figured out it's not what you thought it was. So the name is sticking around. And the fossils that I have on display of it are two maxillae and the quadrate. So the maxilla, as you can see, is the part of the jaw that has lots of teeth. So these are rows and rows of teeth that these herbivores are using to, take in plant matter and grind and shear it down. So that's these two pieces. So this one is the right maxilla, this one is the left, and this piece is the quadrate. So this is part of the skull that's kind of behind the eye in the back. This is the left, so it would be on this side. So we've got three pieces of an herbivore dinosaur skull. If you want to go into here for a little bit more detail, you can see this panel over here with look at the maxillae. You can also turn around here and see two different bones. These are the same type of bone, but from two animals that are almost 20 million years apart. So this is that same quadrate from Nashoibitosaurus on the right, and then Hayawati on the left. So this is a hadrosauroid, not a true member of the duck-billed dinosaur family. I keep going like this because they turn out to not actually have duck bills. They turn out to actually have like a keratinous beak that looks more like an oyster. But duckbill is what people know it as, so that's the name that's going to stick around for generations, I'm sure. So this is that same bone, the left quadrate, but from a much older animal, also found in New Mexico. So if you want to do a direct comparison of what those two look like, this is a good place to do it. And because the real things are kept hundreds and hundreds of miles apart, this is basically the only place you can just, within a couple of seconds directly compare these two fossils, which I think is pretty cool and speaks to like what the purpose of a virtual museum like this is. Here's another map, and you can again see that the continents are a little bit different from the way that they looked in the previous exhibit, and you can see that again right here is where that meteor is going to strike, and we are just up there. But at 73 million years ago, when the Kirtland Formation was being laid down, that's millions of years away. They don't have anything to worry about. The last dinosaur that's on display here is called Zeopelta. It's an armored herbivore, and these are bones that are part of the armoring around the neck. So there's some technical terms that I have listed in here. Right lateral first cervical ring. That's this particular piece. And we have two more that are also from the neck of Zeopelta. So if you're really curious, like, what does that actually mean? I have some diagrams that are in this little room that show this is the cervical ring, basically the armor that sits around the neck. These dinosaurs, these club-tailed dinosaurs, are heavily armored, and you can take a close-up look at the skull here and see, yeah, it's really heavily armored. It's got spikes. This is the eye right here, so it's a very heavily armored animal, and they have these rings of spikes around the neck as well, which I think look really cool. And so if you want to actually know, like, what does the medial position look like? Well, it's this one that's kind of closer to the top. What does the lateral position? It's the one that's more in the middle. And then the distal position is the one that's closer to the ground. So that's these three pieces of Zeopelta. And for now, that's all that I have on display in the Kirtland Formation. Again, hopefully I will be able to display more as time goes on. But for the moment, we have to plunge back in time just a few million years and visit another Cretaceous deposit in New Mexico. So we've barely moved. We've just gone back from 75 million years ago. Or sorry, 73 million years ago to 75. Welcome to the Fruitland Formation. And this is a very similar ecosystem. It's the same place, just a few million years older. And this is a place I was actually able to visit where the exposures of the Fruitland Formation are. And in this case, I was able to scan a handful of actual tree stumps. So this is a real petrified tree that is sitting on its side out in the Badlands of New Mexico, and I was able to actually take photos of it and make a 3D model. So this is a specimen that will never be collected. You will never see this in a museum because it can't be. It's very large and it's hundreds of pounds, and you would probably destroy it even by trying, right? And you can see the roots are still going back into the rock. So this is not something that's ever going to be removed, but because I went and took a scan of it, there is a permanent preserved version of it. It's not the same as having the real thing, but it's better than nothing, right? And the scan is actually high enough resolution. I can see it because I'm looking at this on my 4K monitor. You guys let me know how it looks on your devices, but you can actually see, for me, I can see growth rings on the tree. So I did a good enough scan of this thing that you can even actually see the life history as this tree grew. 75 million years ago, which I think is very cool. So what animals are available to see in this exhibit? So I have fossils of Deinosuchus. This is a very large reptile that has been on display in SHADOWBOX before. You can find fossils of this in the Menifee Formation as well, which is another deposit in New Mexico that's about 5 million years older than this. So one of the really cool things about SHADOWBOX as I'm filling out these exhibits is you're able to move forward and backward in time in these same areas and actually see these ecosystems continue to evolve. So we've got 2 osteoderms. These are armor that sit in the skin of the animal, and Deinosuchus is really distinct in that you can see just how thick and inflated they are. They kind of balloon up almost like if you've ever mixed like a really thick pancake mix, and they just kind of sit and bubble like this, and they get holes on the top. That's kind of what I think of when I look at these. Very different from those osteoderms of Acanthosuchus, right, in shape, and also very different in size. These are much bigger. And in addition to that, there's also this part of the jaw. There you go. So you can see these are called alveoli. These are the holes where the teeth would have gone. You can see there's much bigger holes for bigger teeth here at the front. And this is part of the lower right jaw. I'm noticing that I have it listed here as the lower left. So again, I'm going to make a little note here to adjust that. You work for hours and hours on this stuff, and then as soon as you're putting it in front of people, you realize that you've got typos here and there. So I'm just going to make a note of that to go ahead and fix. I'll probably push an additional update sometime, when I get back from, I'm taking a short vacation at the end of this year, and in early January, I'll do some bug fixes and stuff like this. So I'll go ahead and make a note of that. I'm pointing this out now on stream so that other people don't have to go through the process of pointing it out. I've seen it, I'll take care of it. So no bonus points for correcting me on that. I have already figured out. You can even see right here, I wrote it correctly, lower right jaw. Anyway, so you can get a little bit more anatomical detail in this little area and then teleport to the Cretaceous period in the Geological Eras tour if you wish. I do not wish to do that right now because I'm going to show you 2 of the other trees that I scanned out in the Fruitland Formation. This was a really cool one. It's a tree stump actually, and what you're looking at are the different roots that are radiating out. And it's got this bright red coloration for a lot of it because it's covered in lichen, which is really cool. So here we've got roots as they splay around. If you're interested in learning about what different sorts of dinosaurs and other types of reptiles were here, here they are. Bastahia versor has also been found in the Fruitland Formation. Deinosuchus we just got to look at. There are little raptor dinosaurs, Sauronitholestes, this tube-crested herbivore, Parasaurolophus, and the horned dinosaur Pentaceratops. One day I will have scans of all of these things in this exhibit, but for the moment, this is what I've got. And I'm going to show one more tree that was scanned. This one is a very long trunk that's kind of sitting on its side here. And for scale, I have this photo of me sitting next to it. There's me. You can tell that it's me because I've got the mineral sunscreen on that totally whites my face out. So just for perspective, right, we'll say 6 foot with my shoes on. There's debate among my friends how tall I actually am. I maintain that I'm 5'11" because that's what doctors tell me. And when I say that, people get mad and they're like, no, you have to be at least 6'1". I think most people are lying about how tall they are. So there's some perspective. We've got a question in the chat. How did you get into paleontology, and do you have any recommendations for someone starting out, books, online resources, and stuff like that? Paleontology has been a thing that I've just kind of always done. Back as early as I can remember, this has been a thing that I was really, really interested in. And so I don't remember there being any kind of inciting incident. I guess I just found out one day, as everybody does, that there are ancient fossils out there of things that lived millions and millions of years ago that are completely extinct and can't be found today. And that totally just blew my mind. And I have yet to be able to satisfy my curiosity about that. And I suspect that I probably never will. So the question to how did you get into it? I don't know. I just kind of always was. Now, if you want to get into it the way that I'm into it and just flood your mind with information as much as you possibly can, there are a couple of different ways to do that. There are lots of books. I have many of them on my shelves back here. Don't look at what's over here. This is a mix of my books and my partner's books. No one's pointed out yet the copy of Dianetics up there, but I'll just clarify that I'm not a Scientologist. We have collections of different stuff. There are books out there that you can read. Obviously, the older the book is, the more you should be cautious about stuff being out of date. The classic that people recommend that's fairly recent would be Steve Brussetti's Rise and Fall of Dinosaurs. That's as good a place to start as any. But if you have interests that are not, strictly speaking, dinosaurs, I always recommend people look into what's local to you. In most cases, there will be fossils somewhere near you. They might not be as rich as in the Southwest where I grew up. So having close proximity to fossils is a big reason why I think this stuff grabbed me so profoundly. But even if you're in a kind of place that doesn't have a lot, you probably still do have a museum nearby. And so I recommend going to see real fossils. Because just looking at photos or just looking at replicas is not going to really do it. You can see if you can get access to real fossils by volunteering in a museum, volunteering at a university, that kind of thing. I, of course, have to plug that if you enjoy learning from me, I run a Patreon page that has a subscription that is only $3, $3 a month if you want to get access to one new article a week. Some of those end up for free that are here in SHADOWBOX. Others are kept exclusively. So $3 a month if you want to see, get a new article a week and get to read the entire backlog. And subscribers that are paying $6 a month are getting access to Q&As. So there's a lot of more specific questions that people have. For $12 a month, you get to see the videos and the archive of videos from my fossil collecting expeditions, where I actually shoot it from the field. So you can see the videos of me out in the Fruitland Formation taking photos and scans of what is now on display. So definitely check that stuff out if you're interested in this kind of thing. And you can sign up for the Patreon for free to get updates on other stuff as well. Like I do this stream every week. SHADOWBOX obviously is a resource I'm trying to put together specifically for this purpose, for stuff that's free. I'm going to quickly detour and talk a little bit about this exhibit. So this is slightly older than the Fruitland. We're looking at 74 to about 75 million years ago. And this is southern Arizona. So this is stuff that is pretty close to me in proximity. So these are some fellow southern Arizonans, and we've got two different types of dinosaurs here. There are the Tyrannosaurids. We don't actually know which genus and which species is present, but we do have Tyrannosaurid teeth, so we know that they're here. And if you zoom in really close, you can actually still see the serrations on that cutting edge of this tooth, which I think is really cool. So we've got a couple of different teeth from this animal. And then we also have a portion of the skull of a horned dinosaur called Crittendenceratops. named after the Fort Crittenden Formation. Again, this is I am not a fan of people just naming animals based off of the place that it came from. I would prefer we be a little more imaginative than that, but I'm not the one who named it. So there you go. This is Crittenden ceratops. You're looking at the squamosal, which is kind of the lower part of the frill here. This upper part is called the parietal. And there's lots of bones in the skull of Crittenden ceratops that we don't have. And so these portions that we don't know are restored after a close relative called Pseudoceratops. So hopefully we find more material of this animal and we're able to show whether, this reconstruction that I've kind of vaguely put together, whether it's more like this, whether it looks completely different, closer to Zuniceratops or something like that. So here's Crittenden ceratops. We have another question in the chat. How did you start doing fossil prep? I've been doing fossil prep on and off for quite a while. I would say, well, it's interesting because when you start off, like I did with field excavation, you kind of get a lot of the same, you learn a lot of the same techniques, but you're never getting quite as close to the bone as preparators do. So in the field, when you find something like this in the rock, you're going to go around it. You're going to give a couple inches of grace on either side and make a pedestal to kind of isolate it, and then put a jacket on top, cut it off on the bottom. I have lots of videos of me doing this in the field. If you're one of my expedition donors, you can see all kinds of stuff like that. But when you're a preparator, you're using, in my case, I have a tool that is essentially like a hollow point needle that is pushing air. And it's delicate and it's fine work so that you can go just little bits at a time. And it took me until actually earlier this year to have that equipment. That kind of equipment, air scribes are not easy to get your hands on by any means. And I basically have it out of necessity. I work as a principal investigator on the Menifee Paleontological Project, and we, until we basically spun up our own capacity, we don't have access to a lab to prep the stuff ourselves. So I'm actually very much still a student of fossil prep, although way back in the day I had done a little bit of prep on fossil fish, some stuff from the Green River that I collected at a commercial quarry. And that's something of a similar technique. You're using, it's not air, but it's more of like a vibrating device that kind of separates the different layers. I would say if anyone who wants to learn how to do fossil prep, you're basically going to have to find an existing laboratory to learn how to do that kind of thing. Again, a museum or a university, and there are also commercial companies that do this stuff too. And you may not be able to find a gig that pays you to learn how to do it, but there are often internships sometimes. And museum volunteer work is unpaid, but it's the same kind of thing. If you want to learn how to do it, there really aren't that many options. So that's a Fort Crittenden. We've got through, which I just stepped into by accident. So again, this is southern Arizona, and those are our 3 Cretaceous exhibits. So there are still 2 more that are currently listed in here that will be opening in 2026. That's the Cliff House Sandstone and then the Atarki Sandstone. These are Cretaceous marine units that I had aimed to get out this year, but I actually need more time to research the snails. Actually, it's the gastropods that I want to spend more time with before I end up opening up those exhibits. So these 2 I'm working on, but those are going to be opening in 2026. But these 3 in the back here are open and ready to go. So that's in the Cretaceous. We're going to move way back to the Permian, and we're going to go ahead and jump into the Dunedoo Formation. So this is the first exhibit that I've displayed of Australian fossils. These come from New South Wales. And these are about 252 million years old. So this is much older than the stuff we were just looking at, which is around 75 million years old. And there's a lot of historical significance to these fossils here. So these are all leaves of a species called Glossopteris browniana. There are 4 different chunks here that you can look at. that have different portions of leaves. So you can see these are kind of tongue-shaped leaves, so they start off rather narrow and they get kind of broad. You can see the vein running through the middle there, and they're present on one side. Some of these have leaves on both sides. This block only has it on the one. And then, of course, if you want to get a closer look, you've got photos, and then this over here where you can see it in better detail. Glossopteris is, when it was alive, was a type of tree that lived all across southern Pangaea. So compare the map of what you saw in the Fort Crittenden with this map. Everything looks completely different. All the continents are totally smushed together. And the southern region of Pangaea was covered in forest of Glossopteris. This whole region down here, it was still cold, but there was no ice at the poles. So this is a period of time in which there's no ice, and we have a proliferation of different plant communities, and Glossopteris is by far the most iconic. Like, if you've ever heard of a Permian plant, which most people wouldn't have, but if you've ever heard of a Permian plant, you've heard of Glossopteris, because they can be found on in Australia, clearly. They can also be found in India. They can be found in Madagascar. They can be found in Africa. They can be found in Antarctica, and they can also be found in South America. So this species is actually very historically significant to our development and understanding of like continental drift. This was a serious part of developing our understanding. This right here is not something that we understood even, 150 years ago. We have a comment about digging up fossils in Kemmerer. They also sell air scribes for surprisingly cheap. There's an online store. You can get them for about $300. Yeah, it was, Kemmerer was also like where I had gone to that commercial quarry to get Green River stuff. So I would definitely say that that's, if you want to learn how to do prep, it's a little bit different from like prepping a dinosaur fossil, but it's still, valuable stuff. And there are actually commercial opportunities. Like, if you learn how to prep Green River fish, you can get paid to do that professionally. So I would definitely recommend look into that stuff. If you can find air scribes for cheap, go for it. All I know is the one that I have was not cheap. The one that was recommended for working on terrestrial rock and stuff like that. And also in here, again, we've got the article on Glossopteris you can read, but I also put together a bonus blog called The Ghost of Glossopteris. And so that's an exploration of not just the plant itself, but some musings on climate change and extinctions, and in a lot of ways, I would say, when you take a serious, realistic look at the changes that are happening to the planet compared to the change that have happened in the past, there is a lot to be worried about. But I also find that the conversations you see online about climate change, in every, basically any circle you go into, is not often centered and not, I would say, having both feet on the ground as far as like what actually happens during a mass extinction. The mass extinction that wiped out Glossopteris also wiped out north of 75% of all species on the planet. And there are estimates for various groups. You can read all about that in the article, The Ghost of Glossopteris. But it is very much possible. This was a mass extinction that was driven in large parts by global heating caused by fossil fuel emissions and ocean acidification. So there's a lot to learn from this extinction, but that situation is also very different from what's happening today. And so I kind of go into like what is actually realistic to expect, what do scientists actually say about how the climate is changing today, and what can you actually do about it. I think there's so much talk about what we can't do, but there are things you can actually do. And this is coming from the opinion of not just a paleontologist, right? But I currently work in a lab that focuses on ancient climate and climate change. So these are conversations that I am having and listening to at work all the time. And I think that I just sat down and wrote a couple thousand words because I think that the public really, really could stand to... we need to bring the public into these conversations, because what I see happening online where people are so afraid and think that human extinction is like a couple of decades away. I'm never considered an optimist, or I would say I'm most often described by people I know as being deeply cynical, and even I have to say, like, human extinction is not happening in 20 years. There are certainly groups of people, and there are certainly many species of other living things that are very much at risk and could be gone in 20 years. But to wipe out all of humanity in that time would require, a nuclear apocalypse. That's like, if you're worried about human extinction, that's what you actually should be concerned about. Climate change is a very serious problem, but it's a different beast, I think, than people kind of have in their heads. So this is probably my favorite exhibit that I put together of the batch, just because there's so much relevant to today. And Glossopteris, this simple little tongue-shaped leaf here, is so important to the development of our understanding of how the planet changes, because we can find it across all these different continents that once upon a time were smushed together. But we didn't even really know that until research of Glossopteris, among other things, actually took place. So that's 5 we've gone through. There are 2 more exhibits to go. We're going to continue to go back in time. This time we're skipping over to the Carboniferous to hang out in the Westerville Formation. These are fossils from Missouri. So my first set of fossils from that particular U.S. state. And there's 3 of them. These are all belonging to the species over here, Linoproductus pratinianus. And these were 3 shells sitting in a box in the collections at U of A, where I work. And I thought that they just looked beautiful, and I scanned them. And I thought, well, that would actually be perfect to make a nice, tidy little exhibit. You can see all these little striations, and then those little bumps here. If you can see these little bumps, these were actually the bases of spines, where the shell would sit in the mud, essentially, and the spines kind of help them sit suspended so that they're not sinking into the mud. Linoproductus belongs to an order, Productida. These are the producted brachiopods, and they were extremely common throughout the pre-dinosaur era, the Paleozoic. In fact, if you go through SHADOWBOX, you can find a number of productids, including in the Permian and elsewhere in the Carboniferous. So if you jump over to the other Carboniferous exhibit that's open right now here in the Naco Formation, I'll just jump in there, why not? You can also see Linoproductus fossils. But these ones are actually agatized, so they are like bright red, which is really cool. But we're not here to look at the Naco. I'm going to go ahead and jump back in time once more. So we went from 252 to 305. That's how old the Westerville is. And again, this one is fairly small. It's the 1 species, and just some very beautiful detail here. You can see all of the costae, or those striations there, and the broken spine bases. So this is a really cool place. Again, look at the map, check out how different it was, moving back about 50 million years or so. Thank you. Yes, I have been busy. I have been working very hard on this for, I think, 26 months is how long SHADOWBOX has been in development. And the open access, or the early access open beta testing has been available for almost a year. So it first opened up on January 1st of 2025. And so in just a week or so, we will be at the 1-year anniversary. And so I really wanted to show off a bunch of new stuff. The last exhibit that I'm going to show before I pass out, because it has been a long day, is the Louisville. As people around it would probably insist I call it the Louisville, but whatever, I'm not from Missouri, sue me. And this is the first exhibit that I've opened in the Silurian period. So this is the oldest of the batch by far. here's the map in the Silurian, and we are at a whopping 430 million years ago. So look at how different the map looks after this period of time. So the Silurian is a period in which most life is going to be still in the sea. However, the Silurian is the time period in which the very first land plants can be found, Cooksonia. I very much would love to scan some Cooksonia once, someday I'd like to get my hands on some. For now, we've got this beautiful arrangement of different corals. So these are all from the same deposit, the Louisville Formation, and they are all from Kentucky specifically is where this stuff is from. So this is a big guy called Favosites. These are things that I found in a drawer at U of A where I work. And I accidentally hit the teleporter again. Give it 1 second. And a lot of these are part of the University of Arizona Laboratory of Paleontology collection. You can see UALP here on the side. But only the Favosites was actually accessioned. So these ones over here are part of the UALP, which shut down in 1996, but they weren't ever given specimen numbers. And so one of the things that I'm hoping to do as a little bit of a personal update, I actually applied to do a PhD program at U of A in the Department of Information. And one of the things that I'm hoping to do, because this collection of fossils that I'm helping to share as widely as possible, definitely needs some it needs some love. There's a lot of information that can be updated. For example, if you wanted to research this particular cool little piece of coral, it doesn't have a specimen number yet. So there's a lot of work to be done in that area, and hopefully within a couple of months I will have good news, and I'm really hoping that I'll be able to be the person to help give these guys, register them, accession numbers, build the digital catalog that we really need to be able to work with these fossils scientifically and not just here in an educational context. We've got a bunch of different species. Plasmapora over here. I really like these guys. They're just these, they're sort of small and squat. These ones are a little more globose, and they've got all these little openings right here. Of course, Cnidaria up here, the phylum. Cnidaria is coral, but it's also jellyfish. Believe it or not, those two organisms are very closely related. And so what's in the coral, actually, what's building these skeletons, are tiny jellyfish-like animals, the polyps, that live in here. And they're grabbing food out of the water column. Some of them have photosynthesizing endosymbionts, different organisms that live inside there with them that help produce nutrients. So within the group Cnidaria, we have tabulate corals. These are a few of them. This one is also tabulata. This guy is also tabulata, Heliolites. I forget the name of the phobia where you hate little holes in objects, but if you have that, this is not a great exhibit for you. I'm sorry. Over here we've got, this was another one that I absolutely love, Triplasma. And these are really tiny buggers, so I'm really happy with the way that these scans came out because the actual object is just puny. These are so small. And they've got all these cool ridges. So these are basically where, it's kind of growing on top of itself over time. And you can rotate these around. Triplasma is from the class Rugosa, so these are actually rugose corals. They're somewhat... Yes, trypophobia. If you have trypophobia, you should have stopped watching about 10 minutes ago. So these are relatives of horn coral, which can be seen... this is one of them over here, kind of horn-shaped coral, Phyma. And these ones all tend to have this kind of shape. They have the apex down here at the bottom. This is where they attach the substrate. Up top, you've got all these radiating, these are called septa, I believe. Let me check my notes, which I have available for you to also see. Yes, these are called septa in plural, septum individually. And you can even see on the side here, these are little growth rings. So just like trees and just like a lot of other animals, this is where the animal is adding new material on as it gets older. And I completely skipped over Arachnophyllum. This is another really cool guy. Again, just this really big chunk. You can see it on both sides where it's kind of building up on the surface of the rocks. And yeah, over here is where you can go to see. So all of these have something called a calyx, or a similar sort of structure where the individual organism, the individual polyp, is living. So this is a colonial organism, and they're all living smushed together. And the very last new fossil on display for this update, and the last one I'm going to show you for this year, is Strombodes. This is another really cool type of branching coral. It's in the class Rugosa, so these are also relatives of horn coral, and they're just really neat. You can see that these are obviously broken off and fractured, but they would have formed much taller kind of straw-shaped structures as time goes on. So these are the types of things that are living in the sea at a time when the very earliest land plants are just starting to colonize the land. So in this whole area, this is what North America used to be, that continental plate, and you can see there's lots of near-shore sort of oceanic territory. And then these are the continents, and these are the places where the very, very earliest signs of life on land are starting to emerge. So the Silurian is really cool for a lot of reasons. Oh, and I completely forgot Schlotymophyllum. This one took me, I'll be honest, this one took me a while to figure out how to pronounce. It's named after somebody. I'm suspecting with the last name Schlotheim. I have accidentally teleported into the Geological Eras tour. So if you're interested in this particular hallway, that's what it looks like. This is basically the part of the game where you can walk forward and backward and kind of see stuff evolve linearly. So in each of these exhibits is a little teleporter, including the one I accidentally ran into, that lets you teleport into basically this one long exhibit that goes from the Ediacaran, before complex multicellular life had really taken off, all the way to the modern day. So I guess the actual, there I did it again, the actual last fossil that I'll show you guys is Schlotymophyllum. Let me back in, come on. My teleporter is rejecting me. Okay, so I'm just going to run forward in time a little ways. Actually, I'm going to jog backwards so you can see. Here we're going forward in time, and you're able to see the different sorts of organisms that are alive at these different periods of time. You're starting to get armored fish here in the Devonian. Some more bony fish there. Here's a bunch of different brachiopods and some more bony fish here in the Devonian. So I'm just going to jump to one of my other exhibits, the Silica Formation. And I'll just point out that this exhibit, which was also a bunch of stuff that I just saw in a drawer at U of A that had possibly not been touched in a decade or more, was another thing that I had no idea I would get my hands on this year. So one of the things that's really cool about this update, actually, the December update, beta 1.65, is that all of the exhibits that you can now see, the Louisville Limestone, the Dunedoo Formation, the Fort Crittenden, Fruitland and Kirtland, and then over here in the Nacimiento. These are all exhibits that at the beginning of 2025, I had no idea I would have access to that material. Part of the fun of being a researcher is visiting new collections and just seeing what's there. And in this case, I had not anticipated finding material and getting my hands on and getting permission to scan fossils from these 7 different localities. So that's just part of the fun and part of the surprise for me, is that I kind of don't know what I'm going to stumble into next. That is part of the excitement. And it's the same thing working in the field, right? So one of the exhibits that's going to get a big upgrade in the next year is going to be the Menifee Formation here. This is a place that I'm working actively as a researcher. We can see these are more petrified trees that I scanned from my study area. And over here back in the corner are the different reptiles, including these are more fossils of Deinosuchus, which this was the first specimen, this is the first specimen of Deinosuchus that was ever found in the Menifee Formation, and this was also the basis of my first primary authored publication. I have 2 papers out right now. I am desperately trying to get the third one out. I was not able to submit this year because I'm waiting for some specimen numbers to come back from a repository, but that paper is pretty much ready to submit. And when I do, I will be able to basically put the results of that research here in SHADOWBOX for people to see for free. And the article will also be open access, but this will be a really unique opportunity to showcase what I've learned about these animals in a interactive medium. And just because I mentioned it earlier, here's that fossil of Neuronchilus boweri. So this is, again, just when you work in the field, you come across random stuff. And this is a piece of turtle shell that somebody on the team, I don't remember if this was me or somebody else, but somebody on the team found this in October of this year. And so when I built this exhibit, I had no idea. I had never seen that fossil, that particular piece of shell before. And I went out into the field, we found it, I cleaned it, I scanned it, and now it's available for anybody in the world who has access to a PC running Windows can see this fossil, go up and examine it, rotate it around. So that's part of what I feel is really powerful about this project, is the ability for me to share as much as I possibly can. Because the point of my career is not to be the one who gets to work with fossils and then other people get to hear about it, right? I want other people to get to see as much of this as possible, and get to really get up close and look at look, this is what the osteoderm of Deinosuchus looks like. You can see photos of it in my publication, but to actually get up close and be able to see all of the pits, all of this vascularity where the blood vessels are going in and out of this big hunk of bone that sits in the skin of a giant predatory reptile, you can't tell me that's not cool, right? So that's stuff to look forward to in 2026. There are plenty of other things that I'd like to tease, but I'm not going to. I try to be a little bit self-restrained. I will say that there is a minigame that we've been working on that will be released to coincide whenever the new Menifee croc paper is available, and the coder for that is sitting on the couch right next to me. Say hi.
Hi, I don't know if you can hear this.
Maybe, maybe not. So there is cool stuff on the way, but hey, I think what's available right now is also awesome. So I hope everyone who has been watching, I can see you guys in the chat, so thank you guys for sticking around. This has been going on now for over an hour. It's been really great chatting with you guys. If you're watching this video later on, I think you can still leave a comment and you'll still be able to see it. I will still be able to see it, I'll say. So if you're interested in getting updates on this stuff, again, the Patreon page, that's patreon.com/ptpaleo. Not only is the place where I post updates about the game, I also post my articles and that kind of thing. That's a great place to get updates. You can also join on those articles. You can see a link to a Discord if you want to join the Discord. We've got one more question in the chat here before I go. Can people send you fossils to upload? Here's what I'll say about that. If you have the right to share a 3D model of a fossil, I would love it if you did, because the whole point of this is that I am trying to share materials that should be as publicly available as possible, for scientific purposes, for educational purposes, and all of that. My brief instructions for how to do that, and I'll probably at some point share like a tutorial for how this works, how I do my 3D scanning, which is all just done with my cell phone, right? the same, my personal device that I bring around every single day, this is how I do it. It's very doable. So at some point I'll do a tutorial for how I do this 3D scanning so other people can try so as well. And if you want to donate basically a scan for SHADOWBOX, the key is that you need to share it in a .fbx file type. I would prefer it if you would send an OBJ, an FBX, and an STL if you want to do a donation, but the file type that I use in SHADOWBOX is FBX, so it has to be that. An OBJ will not display properly in here. And if you do want to, I'm actually going to type this in the chat, send.fbx and photos with scale to ptpaleo@proton.me. So if you're interested in doing that, that's the way to do it. You know, in the same way that if you go to just, here, I was talking about producted, so let's jump into the Kaibab limestone real quick. For another member of the order Productita. So you'll see on all of the stuff that I've scanned, which is everything that's on display right now, it says scanned by Benjamin Moeller. So if you donate a scan, you know, assuming you wish to be credited, you know, don't worry, I will write down your name to make sure that you get credit for doing so. It's incredibly easy for me to do, so there's no reason not to. That's a great place to end on, so thank you for that question. I'm going to go ahead and wrap up. Thanks again for watching. Again, this is the SHADOWBOX 1.65 update. I've got a couple of bugs that I will be fixing early next year that I've got written down. So expect another small update in early January. For this year, I have been trying to put out an update at least once a month so that people know this is still an active project. I'm hoping to keep up that same pace in the new year, although, you know, I may be starting a PhD program in the fall of 2026, so that could potentially interrupt it. It could actually mean that I spend a lot more time thinking and working on this stuff, so who knows? Again, I try not to promise anything I can't guarantee, but I will continue to be working on this project for the foreseeable future, of course. And I'll just put it this way. There are other exhibits that I had worked on really hard that I wanted to release this year that are just going to have to wait. There are 2 of them that are hiding behind this wall, for example, in the Devonian. There are 2 more that are hiding behind here in the Carboniferous. There's another one that's hiding behind here in the Triassic. So there are new exhibits that will definitely, it's not going to take 6 months for the next batch of stuff to come out, I'll point it that way. And that's my little teaser for you guys who have gone through and watched an hour of me talking about this stuff. So thanks very much for watching, and I will catch you guys around. Thanks for watching.